Sorry, I pressed a button. Okay, so the question was, why are these minuses? Okay, well, for sure that log 7/2 is in the denominator, so it's getting minused. So everything that comes from that denominator better be minused in the end, because that shows us we got it from the denominator. So this 1 and this log 7/2, they both came from the denominator. So if from now on you just want to think anything that comes from the bottom gets minused, then you can slap a minus on that 1 and that log 7/2 because they came from the bottom. Okay, if you want to do it by hand, just make sure you put like either a parentheses or a bracket before you split up this last term and then distribute that negative into it. Or you can just remember anything that's on the bottom gets minused. Okay. And when I say anything that's on the bottom gets minused, I mean as long as it starts out with multiplication, those two multiplications turn into plus, and then the minus distributes. Okay, let's go to number 6. It's going to be kind of tricky, and you're going to get it kind of confused with number 5. Okay, number 6 first. It doesn't have a subscript, so let's pretend we have a tiny number of who? 10. Yeah, so anytime we have a log without a little number in the bottom, you pretend it's a 10. Okay, so we're going to have log 10 100 minus log 10 and then x plus y. Okay, so far it looks like number 5 where we have something minus something. All right, the only difference is that last something. On number 5, we were able to take that 14 and break it up into things that were multiplied. And then we kept going. Well, look at this x plus y. Can I turn that into things that are multiplied? Nah, I don't see a pretend dot in there. And I don't see two things that could multiply to get x plus y. So, this is going to stay the same. Yeah. If it would have had a multiply dot, then we would have kept working. Or if we could have turned it into a multiply dot, like we did with this 14, we turned it into 7 times 2, that's when we keep working. But I don't see a multiply dot. Okay, so let's maybe try simplifying. This log 10 100, well, 100 is the same as what? 10 squared? And then log 10 cancels, and you just get 2 minus log parentheses x plus y. And you don't have to put the baby 10 down there in the subscript because it's understood or pretend. And again, we don't split this plus anymore because we only split it if we could turn it into multiplication. All right, so there are 2 rules. We have one last rule, or one last property. The last property says that if you have an exponent, like up in the air, or a power, if you have a power or an exponent up in the air, you bring it down in front. That's the best rule ever. Okay, so let's look at number 7. It says use the power. We'll find the power. The power is 5. And so you bring it down in front and bam, 5, ln, x, hot dog. Yeah. Yep. Okay, and then let's try and simplify. If for ln's, I can only simplify if there's an e already in the problem. Dag darn it, there's not. Okay, so let's go to number 8. That's just like showing you we're on the next problem. All right, so find the power. 5, bring it down, bring it down. And we get 5 ln e. But hey, anytime you have ln e, they cancel. So this ln e cancels. And it cancels to whatever the exponent is. Well, what's our exponent of e? Well, it's 1, and some of you are thinking, wait a minute. Wait, isn't she doing too much? Yeah, I am. I'm doing too much. But let's just pretend I did too much. And we went this far. Okay? Well, that means I canceled, and I get big fat 5, big fat 1 from the e to the 1, and you multiply it, and you get 5. Or we could just say, hey, little e, you're pretend. Cankle, exponent is 5. Bam! Yeah, I'd rather do that. Okay, now let's look at number 9. What is this? What is this? Okay, well, you might remember that, like, square root of x is x to the 1/2. Cube root of x is x to the 1/3. You get the point? Whatever number is in the crook goes in the basement. And then whatever number is on top goes in the top of the fraction. For example, this x has an x to the 1. That's where the 1 on the top comes from. This x in the cube root x has a pretend 1. That's where the 1 in the top of the fraction comes from. So this becomes log x to the, there's a fraction. Well, who's up on the x? 2, so that goes on the top. Who's in the little crook of that little square root house thing? 3. So it's a cube root. So, hey, my power is 2/3. And then the power rule says, take that power, bring it down in front. So we got 2/3 times log x. And hey, done with that sucker. And we cannot simplify, because this log has a little pretend 10, remember? Yeah, and 10 and the x won't cancel out. And since it's a pretend 10, you don't have to write it in your homework. All right, so those are the 3 rules, but now let's use them all together. And honestly, what we're doing this first time, making it bigger or expanding it, is much more difficult than the next page of making things smaller. So I know it's kind of awkward, but once we get to this actual combining like terms and condensing and making things smaller, it'll click. But this expanding is more awkward. All right, this sucker says write a logarithmic expression in expanded form, which is what we've been doing. Okay, so first we have to look for our products or our quotients or our exponents. Okay, and let's remember that if we have multiply, it goes to plus. If we have division, what does it go to? Minus. If I have a power, it comes down in front as a coefficient. All right, let's go. On number 10, I see a pretend multiply. So that's going to go to a plus. Then I see a division. So that's going to go to a minus. I'm going to stop drawing these arrows. It's too confusing. Okay. So, and then we're going to distribute. And remember, it's kind of like we distribute top to bottom. So I'm going to start with a log 3, 5, where 3 is the only thing in the subscript. Okay, then that dot goes to a plus. So plus. Now I'm going to talk about this z, but I have to put the log 3 on it. So log 3z. All right. Now I'm going to move to the bottom. Has a w in it. When I do write down the bottom, I have to put a minus because it comes from the bottom. So minus, but don't forget, you put a log on everything. So log 3w. Hey. And then the last thing is to check the subscript with the big number, 3, 5. That cannot cancel. That one's done. Yay. Oh, and neither can the 3 and the z and the 3 and the w. All right, let's go to number 11. First, I see a multiply dot. and that needs to go to a plus. Then I see a division bar, and that needs to go to a minus. But then check it. On the bottom, I see another plus because of that D is multiplied. But remember on number 5, where if we subtracted a bunch of junk, we used parentheses or like a bracket to show when the denominator started. So this 14, I put a minus parentheses log 714 to show when the denominator started. So I'm going to put minus open parentheses. I think I'm just going to write myself that note. Parentheses. All right, so let's go. I'm going to put this log 7 on everything, and we're going to read it top to bottom, left to right, like you do a book. So you have log 7a, okay? Then we have a log 7c, but what are we going to put in between those two? A plus. Good. Then we're going to have a minus sign, minus. Then we're going to have parentheses to show that we're starting some kind of denominator. Then on the denominator, it says log 7.5. And lastly, plus sign, log 7d. And some of you are saying, now hold up. On the page before, you said that anything on the bottom gets minused. It does. Watch what happens. When I distribute this minus, sorry, the IT guy is calling me, but I'm not going to answer him. Okay, so when I minus, I get log 7a plus log 7c minus log 7.5 minus log 7d. So this minus gets put onto the L. Okay, maybe I can oh, it stopped. Okay, this minus gets smashed into the front of every L. And now you can see that the 5 and the D are both being minused, and they came from the denominator. And you don't have to write this middle step. If you just want to remember that everything from the bottom gets minused, you can just jump to writing these two things minused at the end. Okay, now let's do number 12. I see a multiply sign, and I see an exponent of 2. So that exponent of 2 is going to come in front, and we're going to have 2 ln x. Okay, and then for the ln y, I'm not going to put the 2, because that 2 is not on the y. The 2 is the exponent of the x, so the 2 has to go with the log of the x. And then that multiply sign goes to a plus. Hey, done with that problem. Okay, let's look at number 13. We already learned how to change up this top. We said that this top becomes x squared, because it was x squared. But then that cube root means you have to divide it by 3. All right. And then, so now that's a power, and that 2 over 3 is going to come in front of an ln. So I have 2 over 3 ln x because the x was in the top. Then this division sign means minus. And then I'm going to have another ln and w plus z. And since there's a bunch of junk in that denominator, I'm going to use parentheses to show it. Kind of like I did on the last problem, or the last two problems. Okay, and this 2 over 3 is not going to go on the second log because it's only on that x. And then we're not going to change this plus to a multiply because right now, all we're doing is expanding. We're going from these symbols to these symbols, as in when you see these last 3, you stop. Okay, so we're done with that one. And we cannot simplify because there's no tiny little e's that could cancel out with this x and both. All right, let's go to 14. First of all, this square root thing is a 1/2 exponent, but it's not just a 1/2 exponent for the 4x, it's the 1/2 exponent for everything. So we're going to say 1/2, then big old bracket or parentheses. And then let's start talking about everything else inside. We're going to have log, what's that baby number? I think that's a 2. 2, big fat 4. And then this 4 and this x are multiplying. So that goes to a plus, log 2x. Then we're going to have minus, and now we need to start doing the stuff for the bottom. So first we have a bracket to show that 1/2 is over this whole 4x, y, z, blah, blah, blah. Then we have a parentheses to show when the denominator starts. So we have log 2y, but then there's a times in between the y and the z. So it becomes a plus. And then we have log 2z. But that z had a 3 in the air. So the 3 needs to go in front of the L. Okay, and then you can either distribute from here, or you can just keep it this way. Let's see if we can simplify it. Simplify, remember, it's when the tiny number matches the big fat number. Let's see. Tiny number 2, big fat z, no, can't do anything. 2 and y, no. 2 and x, no. 2 and 4, maybe. This 4 is the same thing as 2 squared. Yeah. And then all that cancels out to just a big fat here. Yeah. Okay. So we have 1/2 bracket. All this hoopla of log 2, 4 went to just a big fat 2. Plus log 2x. Let's go ahead and distribute this negative. So we'll have minus log 2y minus 3 log 2z. And then if you wanted to distribute even more, just remember that when 1/2 multiplies by 2, half of 2 is a 1. So this answer would have a 1 in it if we were to distribute anymore. Okay, but that's good enough for that one. All right, let's look at this big boy, number 15. Okay, first let's try the multiplies. Where are the multiplies? Multiply, 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 and multiply. Okay, and then instead of doing this whole distributing junk, why don't we just remember minus anything from the bottom? So let's try and skip this whole parentheses bottom and just start writing minus. Okay? Okay. So we're going to have log little 8, 64. Remember, we read top to bottom, left to right, and we distribute that log 8 to everything. So log 8, 64. Then the 64 and the x squared have a multiply, so that goes to a plus. Then log 8x, but there's a big fat 2 in the front because that x had a square. Then we have plus log 8y. And then now let's go ahead and minus everything from the bottom. And instead of writing minus open parentheses and then distributing, we're just going to minus everything from the bottom. So minus log 8, 3 minus log 8z minus log 8w. And that last w should have a big fat 3 in the front because that w had a 3 in the air. All right, let's see if I can simplify anything. 8w, those are not the same. 8z, no. 8-3, no. 8y, no. 8x, no. 864, maybe. I could change that 64 to ocho squared, and then pow, that cancels out to just that big fat exponent of 2 plus this stuff. Yeah, I'm not going to write it all over again. Okay. So our answer would be 2 from this log 8, 64 plus all this other junk because it did not cancel. All right, so that was expanding. Now we're going to condense. And condense is another way of saying write the logarithmic expression as a single logarithm. Yeah, with a coefficient of 1. Yeah, so what we're about to do is called condensing. Or now we finally get to combine like terms. And the only way we can combine like terms is if their subscripts match. Those tiny things down underneath in the basement. All right. So when we condense, we go backwards of these rules. So instead of going from multiply to plus, we go backwards. For condensing, we go from plus to multiply, minus to division, coefficient to up in the air as a power. Okay, and our answer only has a single logarithm. So every single answer will only have one log. It will not have logs sprinkled throughout your answers. No, it's just going to have one of them. All right, so let's look at number 16. We have log. All right. And then what do we got? We got some kind of junk, okay, minus. This minus before the L means that's becomes the division. So the minus before the L becomes the division, not the minus before the 3. It has to be the minus before the L. All right, so we have two terms, log 4x minus 3 and log x. To squish them together, we're going to put the 4x minus 3 on top. And you can put it in parentheses if you want, and the x on bottom. Yeah. Okay, so another way to see that is log, and then a big fat parentheses with a fraction of 4x minus 3 over x. And that's it. You do not cancel the x's because they can't. Because they cannot cancel with that 3. All right, let's go to number 17. It says log 2. We'll first put a log little baby 2 down. That little baby 2 never changes. It's the same. Okay, then I see log 2z. So I'm definitely going to have some kind of z action going on. Then I got a plus, which means multiply. Then I got a 4 log 2y. So I'm definitely going to have a y. But remember, the coefficient, the thing in front, goes up in the air. Okay, so our answer is log 2 zy to the 4th. Or you might see it as log 2 and then zy 4 in the air. And the only things that are small are the 2 in the subscript and the 4 in the air. All right, let's look at 18. We're dealing with LNs this time. So we're going to have one LN, just one of them, okay? And then we're going to have, what does it say? X. Okay, X. There's my X. But it has a coefficient, so that 3 goes up on the X. Okay? Then we have plus sign. What does plus mean? Multiply. So we put a multiply dot. And then we multiply whatever comes after that LN, which is X minus 2. Okay? Then minus means divide. And you're going to divide everything, not the LN, just the letters, X's and the numbers. And then you're going to divide by LN, what are we doing? LN of 5, so we're dividing by 5. Hey, so that's our answer. Or you might see it as LN, and remember your homework uses lowercase ln. Anyway, but you might see it as LN with X3 and no little dot. Or you could even multiply it out. All right. Yeah, aren't these much better? Okay, looking at number 19. You're terrified, but it's okay. Let's see. We have a LN. Let's see what we got. We got a 2 in front, so that means that 2 is going up here. This 2 does not go way over here to the z. It only goes to what it's attached to. So it stops at the bracket. Okay, so we're going to definitely have a ln of a x. Okay, there's my x. Okay. Minus, that means divide. So divide. ln of x squared. Okay, put an x squared on the bottom. Okay, and then all that's in a big fat parentheses or bracket, so we just took care of the ln x minus ln x squared. Now all of that is in a parentheses or a bracket or whatever, and it's squared because that 2 in front. Okay, let's go ahead and deal with that first before we deal with all this other witchcraft. Okay, so let's maybe just figure out what this is going to become. If I square this, you get ln x squared over x to the 2 times 2 is 4. Okay, and then if we use those rules from exponents where if you divide like bases, you subtract the exponents, this becomes ln x 1 over x squared. Yeah, okay. And 1 over x squared is like saying ln x to the negative 2. What? Remember, things that come from underneath a 1 can be transformed to dropping the 1 and using a negative exponent. Okay, so all this hoopla is ln x to the negative 2. Okay, let's keep going. Then it says plus sign, that means multiply. ln z to the 9th. See the z to the 9th? But what does the 2/3 do? It goes up and multiplies it. So 9 times 2/3. Okay. And then it says minus. That means division. ln z to the 1. So z to the 1 on the top. Okay. This looks horrible. Let me rewrite it. Okay, so this should have been ln, and I'm only supposed to have a single log, so I should not have written this one. Moron. Okay, me, not you. Okay, so I have ln, like a single log, ln, you see it, okay. Then we have x to the negative 2, z to the, let's multiply 9 times 2/3, and if you forgot how to multiply 9 times 2/3, you put a pretend 1 underneath, and then you multiply left to right, and you get 18 over 3, and then divide to 6. Or you could have done 9 times 2, 18, divided by 3, 6. Either way, that makes z6 over z1. Okay, remember that rule we used right, what was it, here? Where we subtracted 2 minus 4 makes x to the negative 2. That's how we got x to the negative 2. We subtracted the exponents. Same thing here. These exponents of the z need to be minused. All right. And then remember earlier where I said anything with a negative exponent comes from underneath? Okay. So I'm going to put this x to the 2 in the bottom. So our final answer needs to have one single log, ln. Done. Our final answer has z to the 5th in the top, and then the x goes on the bottom with a 2. And it goes to the bottom because it had a negative exponent. All right, let's go to number 20. Okay, first, we're going to have log 5 because we need a single log. Then I'm going to have x plus that. Okay. because I see this x plus 5. But what exponent is on him? Well, dag darn it, I got to bring up that negative 2. Dag darn it. Okay. And then I'm going to have a plus sign that goes to multiply. Log 5 dat x. Don't write the log 5 again, because you'll make the mistake that I did on this last problem. Remember, we're only supposed to write ln or l whatever once, because it's a single log. Needs to be our answer. So that's why I just wrote log 5 once. Okay, so we got this x. Then I see another plus sign. That means multiply, just like the last one did. And then we have x squared minus 25. All right. All right. Okay, we could stop there, but it says simplify as much as possible. So let's go. First, we're going to use that trick where we take the negative exponent and swing that guy down to the bottom. Okay. The second thing that we're going to do is we're going to try and factor this x squared minus 25 because it's a difference of squares. And I'm thinking maybe it can cancel and we can make all this way smaller. Okay, so we're going to have log 5 fraction. The x plus 5 to the 2 goes to the bottom. And when it goes to the bottom, the 2 becomes positive. On the top, I have an x. I know that x stays on the top because he does not have a negative exponent. On the top, I have x squared minus 25. And if you forgot how to factor a difference of squares, differences of squares, if you can make it look like x squared minus a number squared, it factors to x plus that number, x minus that number. So for us, we have x squared minus 25. Well, if I can change that 25 to maybe 5 squared, this becomes x plus 5, x minus 5. Okay, we just factored this x squared minus 25 to x plus 5, x minus 5. Okay, let's see what happens next. I can cancel something. This x plus 5 on top looks just like the x plus 5 on bottom. Only, I don't want to cancel out all of this x plus 5 squared. I just want to cancel out one of them. Yeah. Okay, so let's write our final answer. We're still going to have, okay, I think I can fit it here. We're still going to have that log baby 5. We're still going to have a fraction, but on top, we just have x and x minus 5. On bottom, we have x plus 5. And they might be in massive parentheses. And no, we cannot cancel out any x's. All right, now it says use log b2 and log b3 and log b7 to approximate the value of this. Okay, so let's just kind of play around. I have the numbers 2, 3, and 7. Let's try and break our 21, 9, and 7 over 2 into some kind of combination of 2, 3, 7. Let's see what we can do. How can I change 21? I can change 21 into 7 times 3. All right, so we got log b7 times 3. All right, what do multiply symbols turn into? Plus. So we have log b7 plus log b3. And then now we just have to add the decimals that represent these. So let's see what the log b7 is. That guy's the 1.2 blah, blah, blah. Okay. All right, and the log, this is supposed to say log b3. I wrote log 3. Okay, this log b3 was 0.6826. Hey, so this is 1.8917. Okay, let's look at this log B9. We need to try and switch this 9 into some combination of 2, 3, 7. Okay, well, I think 3 times 3 is 9, right? So this is log B3 times 3. Okay, and that does not mean you're going to multiply their decimals, because watch what happens. This multiply turns to a plus. Yeah, multiply turns to a plus. And then now we have to add the decimals. So we have to add that 0.6826 plus 0.6826. We get 1.3. All right, last sucker. We don't have to split it up because they kind of already told us what to do. Log B7 over 2. Well, division means minus. So let's switch this into log B7 minus log B2. And so now we're going to minus the decimals. We got to do the decimal for the 7 first. So minus the decimal for the 2. And this is more like the math that astronauts and fancy math people, scientists use, because there's a piece that we don't know. It's that B is missing, so that could be some distance that we don't know, and we're trying to figure it out, but we're still able to do it. We're still able to figure out what this is equal to, even though we have something missing. And the reason we are is because of these properties of logs. Okay. And then lastly, we should have something called the change of base formula. I know that we have this log button that has a subscript 10. And I know that some of us have this log base, but back in the day, before our calculator had this log base that would use any number in the subscript, before we had this log base, we had a formula instead. So we're about to discuss the formula that covers this log base from your calculator. Okay, the change of base formula says that if you have a little b that is not the number 10, you can change it to log 10 of the top divided by log 10 of the bottom. And that's where this comes from. You could put log, and I wrote the little baby 10 because that comes from your calculator. But log 10 is the same thing as just log. So once we split these up using the formula, we can just press log button top, log button bottom. Okay, and the log of the top is the big guy. Whatever the subscript is goes on the bottom. All right, so this says use change of base formula. As in, what if we did not have this log base and we just had the log button? What would we do? Well, we'd say log of the big guy, 15, divided by log of the bottom guy. And whoa, I don't know what just happened. And then you type it in your calculator. Regular log 15, parentheses, divided by regular log 7. And that should be the same as if we would have used our fancy log base. Okay, and this is for maybe we have some common logs that we know, and we can divide them to get the decimal. So this is for if we did not have that log base, we could turn it into logs that we do know. Yeah, okay. Anyway, so rounding to 4 spots, this 6 is 5 or more, so we got to up the score to 1.3917. All right, for this last guy, you're going to do the log of the big number, 0.3, over log of the smaller number, 5. And don't forget to close this parentheses before you put divided by log whoever. And we get negative 0.748, I think, a 1. Yee. Okay, and again, the answers you get for these should be the same answers you get as if I would have pressed math down to log base. See? Same numbers. Okay, thank you. Have a great day.